I think AI could surpass the combined intelligence of all humans within the next 5 years. Tesla has just wrapped up its Q2 2026 earnings call, and Elon Musk shared a series of major updates about the Optimus program. During the presentation, he even referenced the future Optimus Gen 4, while confirming that production of Optimus Gen 3 has officially started at Tesla's Fremont facility. But that's only part of the story. What's currently happening inside Tesla's humanoid robot division could be one of the company's most significant developments yet. According to Musk, Tesla has officially removed the Model S and Model X production lines at its Fremont factory to create the company's first dedicated Optimus manufacturing line. This is no longer just an ambitious proposal. Tesla has already transformed a section of its long-running vehicle production facility into a factory specifically designed to build humanoid robots. During the Q2 2026 earnings call, Musk explained that the first production runs for Optimus at Fremont are scheduled to begin during the third quarter of this year. However, he also stressed that production will increase slowly rather than all at once. In other words, Tesla isn't planning to manufacture hundreds of thousands of robots immediately because that simply isn't practical. Instead, the initial stage will concentrate on validating the production process, identifying design weaknesses, testing component durability, and gathering real-world operational data as the robots perform actual tasks. The first Optimus robots assembled at Fremont won't be delivered directly to customers. Instead, Tesla intends to use them internally through a program known as the Optimus Academy. The purpose of this initiative is to create a carefully controlled learning environment where the robots can complete tasks, make mistakes, receive corrections, and continuously generate valuable data that improves Tesla's neural networks. This strategy is central to Tesla's long-term vision. Rather than creating robots that only follow pre-written instructions, Tesla wants Optimus to receive an unfamiliar task, observe its surroundings, understand the objective, reason through the problem, and complete the job independently without engineers programming every individual movement. According to Elon Musk, no humanoid robot currently available can truly accomplish this level of generalized intelligence. Many existing humanoid robots can perform impressive demonstrations, but those demonstrations usually take place in highly controlled environments where the robots rely on scripted actions, pre-built maps, simulated training data, or carefully choreographed sequences. Optimus is being developed with a very different objective. Tesla wants the robot to enter an ordinary environment, recognize objects using its cameras, understand instructions spoken in natural language, and determine the correct sequence of actions without relying on predefined scripts. During the earnings call, Tesla's head of AI, Ashok Ellaswamy, explained that the company is training Optimus using a philosophy very similar to the one behind full self-driving. The system starts with pixels as its input and generates control signals as its output. For Tesla vehicles, cameras observe lane markings, surrounding traffic, pedestrians, and road conditions before the neural network decides whether the car should steer, accelerate, or brake. With Optimus, the same fundamental concept applies, but the decision-making process becomes significantly more complicated. The robot must not only recognize what it's looking at, but also decide which object to grab, calculate how much force to apply, determine the best path for its arm, and instantly adjust its grip if an object begins slipping from its fingers. To accomplish this, Tesla is training Optimus using multiple sources of information. The first source comes directly from Tesla employees, performing everyday tasks, while the robots observe and learn through imitation. A specialized demonstration team then produces even higher quality training examples, using more precise and detailed data to verify and improve the overall training dataset. The second major source comes from videos available across the internet, particularly educational and instructional content. This could become one of Tesla's biggest advantages, because the internet contains millions of demonstrations showing people cooking meals, repairing equipment, organizing warehouses, using tools, assembling products, and completing countless everyday tasks in homes and industrial environments. Elon Musk has previously explained that Tesla intends to use videos from platforms like YouTube as part of Optimus' learning process. By studying this enormous collection of real human demonstrations, Tesla believes Optimus can learn entirely new skills much faster than traditional robot training methods. As Elon Musk explained, if Optimus can watch YouTube videos, instructional tutorials, or other educational content and learn from them the way humans do, the robot's ability to acquire new skills could expand dramatically. Instead of engineers programming every individual task, Optimus could continually increase its capabilities simply by observing how people perform different jobs. Even so, it's important to understand that watching online videos alone doesn't instantly give a robot new abilities. Tesla still needs to build AI systems that can connect what the robot sees with the physical actions required to complete a task successfully. For example, a person in a video can effortlessly pick up a coffee mug without thinking about it. Optimus, on the other hand, must convert those visual observations into precise movements involving its shoulders, elbows, wrists, hands, and individual fingers. This is where the Optimus Academy becomes especially valuable. The first generation of robots will operate inside carefully controlled environments, allowing Tesla to collect massive amounts of real-world data. Engineers can then use that information to improve the AI models before distributing the updated software across the entire Optimus fleet. In other words, each robot isn't learning only for itself. The knowledge collected from one group of Optimus robots can be combined, processed, and shared through software updates, allowing thousands of other robots to benefit from the same experience. During the discussion, Elon Musk also introduced another fascinating concept. He suggested that a large-scale digital version of Optimus could exist before millions of physical robots are actually deployed. In this scenario, a digital Optimus wouldn't need a physical body at the beginning. Instead, it could exist inside virtual environments where it continuously processes information, develops reasoning abilities, and learns how to solve problems. Those cognitive improvements could later be transferred to physical robots operating in the real world. This approach allows Tesla to separate the challenge into two major parts. The robot's intelligence can improve rapidly through large-scale digital training, while its physical hardware can be tested much more carefully because it must deal with real-world conditions such as temperature changes, friction, impacts, material fatigue, and long-term mechanical wear. In fact, the durability of the robot itself remains one of Tesla's toughest engineering challenges. Optimus doesn't simply need to complete a task once during a polished demonstration. It must perform the same work repeatedly for hours, every day, while maintaining speed, precision, and reliability. A robotic joint that performs flawlessly inside a laboratory may not survive months of continuous operation in a busy manufacturing facility. Likewise, a robotic hand capable of lifting lightweight objects during demonstrations may struggle when required to handle heavy loads, fast repetitive movements, and constant impacts throughout an entire workday. Elon Musk has stated that Optimus is being engineered to achieve hand dexterity comparable to, or even beyond, that of a human hand. That's an incredibly ambitious objective, because the human hand combines exceptional strength with extraordinary precision. Optimus must be powerful enough to lift heavy equipment while remaining gentle enough to hold a fragile drinking glass without breaking it. It must maintain a secure grip on tools while also being safe enough to operate around people in close proximity. Musk also spoke openly about one of the biggest safety concerns surrounding humanoid robots. An Optimus robot weighing roughly 154 pounds could become dangerous if its control system failed, or if it suddenly lost power and collapsed while operating. For that reason, reliability isn't simply about creating a better user experience. It's an essential safety requirement. Tesla must ensure that Optimus can recognize faults, safely stop its movements, maintain balance whenever possible, or transition into a secure state before a minor malfunction develops into a serious accident. That's exactly why the first production robots will remain inside Tesla's own facilities, where engineers can closely monitor their performance before allowing Optimus to enter the broader commercial market. However, even if Tesla successfully solves the software, AI, and reliability challenges, another major obstacle still remains. That challenge is the supply chain. Optimus doesn't yet have an established global supply network like Tesla's electric vehicles. Elon Musk has mentioned this before, but during the latest earnings call, he once again emphasized that Optimus could eventually become Tesla's largest product, and also the most difficult one the company has ever attempted to manufacture at scale. The reason is straightforward. Most of the robot's components are completely new. When Tesla builds cars, it can rely on a mature supply chain for parts such as tires, glass, mirrors, seats, and body panels. Those components have been manufactured in high volumes for decades by experienced suppliers around the world. Humanoid robots are different. Tesla can't simply place an order for millions of compact actuators, advanced robotic hands with human-like dexterity, or specialized control boards designed specifically for a humanoid body. According to Musk, Tesla must design many of these components itself, while also encouraging suppliers to invest in manufacturing technologies that have never been produced at this level before. In many ways, Tesla is creating the Optimus supply chain from the ground up, because no mature ecosystem currently exists to support mass production of humanoid robots. That doesn't mean Tesla plans to manufacture every single part internally. The company will still depend on major suppliers, especially for technologies that require years of investment and enormous manufacturing capacity. During the earnings call, Musk highlighted Samsung and TSMC as two of Tesla's most important strategic partners. Both companies are investing tens of billions of dollars into expanding advanced semiconductor manufacturing, and part of that future capacity could support Tesla's growing AI ecosystem, including Robotaxi and Optimus. This reveals an important detail about Tesla's strategy. Optimus isn't being developed as an isolated robotics project. Instead, it's becoming part of the same artificial intelligence platform that powers Tesla's full self-driving technology, Robotaxi, and the company's broader AI initiatives. Every one of those systems depends on cutting-edge AI processors, high-speed memory, and extremely low-latency computing. As a result, shortages of advanced chips wouldn't only slow AI training, they could directly limit how many Optimus robots Tesla is capable of building. Musk acknowledged that Tesla still faces several bottlenecks involving memory, AI processors, computing infrastructure, and advanced semiconductor packaging. If even one of these critical technologies becomes unavailable in sufficient quantities, the company's entire Optimus production schedule could be delayed. Another challenge many people overlook is where all of that computing power must operate. Unlike a large data center, Optimus has to carry its computer inside its own body. That means Tesla must deliver exceptional computing performance without producing excessive heat, drawing too much electrical power, or adding unnecessary weight that would reduce the robot's efficiency. Every additional watt consumed by the onboard computer reduces the amount of time the robot can operate before needing to recharge. Because of that, Tesla has to balance several competing priorities at once. The company must maximize computing performance while carefully managing heat generation, battery life, overall weight, and energy efficiency. This balancing act is one reason Micron has become such an important partner for Tesla. According to company statements, Micron has committed a significant supply of memory products to Tesla under favorable agreements, despite memory prices remaining unusually high. This highlights another important reality. The race to build Optimus isn't only about designing a better robot. Tesla is also competing with data center operators, cloud computing companies, smartphone manufacturers, and countless other AI developers for access to advanced semiconductors and high-performance memory. Even if Optimus is completely ready from an engineering standpoint, the shortage of just one essential electronic component could temporarily stop production. That's one of the reasons Tesla continues expanding its vertical integration strategy. The company intends to design a large portion of Optimus circuit boards, control electronics, and specialized hardware internally. The objective isn't to eliminate suppliers altogether. Instead, Tesla wants greater control over the most critical technologies that define Optimus performance. A commercially available component may work perfectly inside industrial equipment, but that doesn't automatically make it suitable for a humanoid robot. It may be too large, too heavy, generate excessive heat, or consume more power than Optimus can afford. Likewise, an actuator powerful enough for factory machinery could still be too bulky, too noisy, or insufficiently precise for the delicate movements required by Optimus hands. As a result, Tesla often faces an important engineering decision. The company can choose readily available commercial components to accelerate development, or invest additional time creating custom-designed hardware optimized specifically for large-scale humanoid robot production. Based on Musk's comments, Tesla appears committed to the second approach for many of Optimus' most important systems. Although this strategy increases development time during the early stages, it could significantly lower manufacturing costs if Optimus eventually reaches production volumes measured in hundreds of thousands, or even millions of units. Elon Musk also discussed another major obstacle Tesla must overcome before Optimus can be produced on a massive scale. Unlike Tesla's vehicle business, where an established supplier network already exists, the humanoid robot industry is still in its infancy. During the earnings call, Musk emphasized that Optimus could eventually become Tesla's largest product, but also the most difficult one the company has ever attempted to manufacture at scale. The reason is straightforward. Many of the components required for a humanoid robot simply don't exist in the quantities Tesla will eventually need. When producing cars, Tesla can source parts like seats, mirrors, tires, glass, and body panels from suppliers that have been building those products for decades. Optimus is a completely different challenge. Tesla cannot simply place an order for millions of compact actuators, advanced robotic hands, or specialized control boards designed specifically for a humanoid robot. Many of these components still have to be engineered from scratch, while suppliers must also invest in manufacturing technologies that have never previously been produced at this volume. Musk explained that Tesla is effectively creating an entirely new supply chain for Optimus because there is currently no mature ecosystem capable of supporting mass production of humanoid robots. That doesn't mean Tesla plans to manufacture every single component itself. Instead, the company will continue working closely with key suppliers, especially for technologies that cannot be developed internally within a short period of time. During the earnings call, Musk specifically highlighted Samsung and TSMC as two of Tesla's most important strategic partners. Both companies are investing billions of dollars into expanding semiconductor production, and part of that future capacity could support Tesla's AI ambitions, including both Robotaxi and Optimus. This reinforces an important point. Optimus is not being developed as an isolated robotics project. Instead, Tesla sees it as another part of the same artificial intelligence ecosystem that powers full self-driving, Robotaxi, and its broader AI infrastructure. All of these technologies rely on advanced processors, high-speed memory, and extremely low-latency computing systems. Because of that, shortages of AI chips wouldn't only slow the training of Optimus, they could also directly limit how many robots Tesla is capable of building. Musk admitted that Tesla still faces constraints involving memory availability, advanced logic chips, computing hardware, and semiconductor packaging technologies. If even one of these essential components becomes difficult to obtain, the entire Optimus production schedule could be delayed. Another challenge many people overlook is that all of this computing hardware must fit inside a humanoid robot. The onboard computer has to provide exceptional processing performance while keeping heat generation, power consumption, and weight under control. Every additional watt consumed by the computer reduces the robot's operating time on battery power. As a result, Tesla has to balance several competing priorities at once, including computing performance, thermal efficiency, overall weight, and battery life. This is one reason Micron has become such an important partner for Tesla. According to the company, Micron has reserved a significant amount of memory for Tesla under relatively favorable agreements, despite memory prices remaining at historically high levels. That highlights another important reality. The race to build Optimus isn't only about designing the best robot. Tesla is also competing with data centers, cloud providers, smartphone manufacturers, and countless AI companies for access to the same advanced chips and memory. Even if Optimus itself is fully ready, the shortage of a single critical electronic component could stop an entire production line. That's why Tesla continues expanding its vertical integration strategy by designing more of the robot's circuit boards, electronic controllers, and specialized hardware internally. The objective isn't to eliminate outside suppliers altogether, but to maintain greater control over the most important parts of the Optimus platform. A standard off-the-shelf component may perform perfectly in traditional industrial equipment, yet still be unsuitable for a humanoid robot. It may be too large, too heavy, produce excessive heat, or consume too much electricity. Likewise, an actuator powerful enough for factory machinery might still be too bulky, too noisy, or insufficiently precise for Optimus hands. Because of this, Tesla constantly faces an engineering decision: use commercially available components to speed up development, or invest more time designing custom hardware optimized specifically for large-scale production. Based on Musk's comments, Tesla appears committed to the second approach for many of Optimus' most critical systems. Although this requires more development time today, it could significantly reduce manufacturing costs once production eventually reaches hundreds of thousands or even millions of robots. This strategy mirrors the approach Tesla has already taken with its electric vehicles by designing custom AI chips, developing its own software, and continuously improving manufacturing techniques. Optimus Gen 3 at Fremont represents the first real-world test of that philosophy. More than simply introducing another version of the robot, it marks Tesla's first serious effort to move Optimus from a research project into true mass production. Every difficult assembly step, every component that fails too often, and every manufacturing bottleneck will provide valuable information for future generations of the robot. Tesla won't only study how Optimus performs while working. The company will also analyze every aspect of how the robot itself is built. After Fremont, Tesla expects Optimus Gen 4 to be manufactured at its Austin facility. Based on current information, Gen 4 is expected to include even more manufacturing-friendly designs, along with a larger percentage of components produced in-house. That represents an extremely important transition, because in large-scale manufacturing, a product that functions well isn't automatically a product that can be built efficiently. If each robotic hand requires extensive manual assembly, or every unit demands hours of calibration before leaving the factory, Tesla won't be able to produce Optimus in the quantities needed while keeping costs under control. For that reason, Optimus Gen 4 won't simply need to outperform Gen 3. It will also have to be significantly easier to manufacture. Tesla is expected to reduce the overall number of parts, simplify joint mechanisms, shorten wiring systems, integrate more functions into individual circuit boards, and eliminate as many labor-intensive manufacturing steps as possible. Every minute saved during production becomes increasingly valuable as manufacturing grows from hundreds of robots to tens of thousands, and eventually far beyond. That's where we'll wrap up today's discussion. What do you think about Tesla's Optimus program? Do you believe Gen 3 will live up to the expectations, or will Tesla need a few more generations before humanoid robots become part of everyday life? Let us know your thoughts in the comments below. We'd love to hear your opinion. If you enjoyed this video and want to stay updated on the latest Tesla, Optimus, AI, Robotaxi, and EV developments, make sure to hit the like button, subscribe to the channel, and turn on notifications so you never miss our future uploads. We bring you new Tesla news, engineering insights, and technology updates on a regular basis. Thank you so much for watching. We truly appreciate your support, and we hope to see you again in our next video. Until then, take care, stay safe, and have a wonderful day.